for our final project, we created an app that can control a scribbler and help with early childhood development by teaching shapes and different drawings. So with this, we had to set up some goals. To begin, we wanted to control the scribbler with our app, our mobile app, and since there was no direct way to connect the app to the scribbler, we had to integrate an Arduino, and along with the Arduino, also some LEDs, and use those different LEDs in different configurations in order to decide which direction we would be moving in.
So in order to integrate 3 technologies into our projects, we had to create certain connections between them. So the first connection was between the Arduino and the app. And in order to do this, we used Arduino serial communication, which sends data and information from an Arduino to a computer, in this case, an Android telephone. So in the app, it checks first, is the button being pressed? If so, it will send a message to the Arduino with a keyword such as forward or left. And then it will check, has the button been lifted? If the button has not been lifted, it will continue to send that same message, and if not, it will send a stop message to the Arduino. And here's a screenshot of our app with the 4 buttons, forward, backward, left, and right.
Okay, so another important piece of our project were the Arduino LEDs, and we use these in different configurations, say like the first one, the last one, just the center one on, and that would help to decide the direction that the scribbler would travel in, or also decide which preset shape to draw. So how this worked was, once it would begin, the app would start sending information, and then the Arduino would have to read this information from the app, and then also turn on the corresponding LEDs with that. And here in our code, you can see the different directions, like backwards, right, and also different shapes like circle, and the different LEDs that would turn on based on the direction we decided to move in. And here in our picture, you can see the Arduino and the LEDs below it.
And in order to communicate between the Arduino and the scribbler, we implemented the scribbler light sensors. There are 3 of them, and they read the values of the brightness of the light entering them. And so the scribbler first checks, are the LEDs turned on? If so, it will move according to the combination of the LEDs, and if not, then it will stop moving. And so in our code, you can see that it checks all the light sensors, and then depending on which ones are on and off, it will give a specific command to the scribbler. And here's our scribbler with the Arduino attached on it.
Here's my demo video.
So in order to communicate between the Arduino and the app, we have to connect the app to the Arduino's Bluetooth. Okay. And then here, the scribbler is moving according to the user input of the buttons being pressed. We also have a shapes tab, where there are 3 pre-written shapes, and when the shape is pressed, the scribbler will draw that shape.
Okay, so our application is geared towards early childhood development. While doing our background research paper, we found a study that stated that young children who are exposed to counting and the alphabet and shapes are more likely to do better than their peers in school because they will be more prepared for reading and arithmetic.
And so some future developments for our app, we would like to include more shapes in the preset part, and we would like to have a beginning level, intermediate, and advanced. We would also like to incorporate a tilt feature where we would implement an orientation sensor to check whether the phone is tilted forward, backward, left, or right, and we would use that in lieu of the buttons. And also games to reinforce learning and shape recognition. And a special thank you to our professors, our teacher fellow, and our teacher assistants.
Thank you.
Okay, so the award for this one is the most educational and the most likely to mess up the carpet by drawing inside.